So students, now we shall look at sign convention for spherical mirrors. So when we want to solve some problems based on the concave and convex mirrors, we have to keep in mind some sign convention. That is, when to use plus, when to use minus, when we have to take minus u or plus u, when you have to take minus v plus v, minus f plus f. Okay. So in this case, there will be some points which we have to remember. Object is always placed to the left of the mirror. Okay. All distances are measured from the pole. That is, we have the pole here, and all distances will be measured with respect to pole. Distances measured in the direction of incident ray are positive. Okay, so this is the incident ray, and all the distances in this direction, if we are measuring in this direction, they are positive. The distances measured in the direction opposite to that of the incident ray, that is in this direction, if incident light is in this direction, then direction against the incident light will be negative. Okay, and distances measured above the principal axis are positive. That is, if this is the principal axis, not if, this is the principal axis, so उसके ऊपर जो हम distances measure करते हैं, it will be positive, and the distances measured below the principal axis will be negative. Now distance along incident line, incident light is positive, so behind the mirror also same case, because incident light is in this direction, so it is applicable in front of the mirror and back of the mirror. But if it is against the direction of incident light, it is negative. So now we shall study about reflection. So now we shall study about refraction of light. Okay, so refraction of light is nothing but bending of light. Okay, now when does a light bend? We know that actually in one medium, okay, light does not bend and it always travels in a straight line. But what if the light travels from one medium to another medium? Suppose from air to water. What does the phenomena take place? That we are going to study now. The change in direction of light when it passes from one medium to another obliquely is called refraction of light. Don't worry what is this word obliquely, it does not matter, don't worry about it. Just to make the answer and the notes fancy, they have used this word obliquely. All you can do is the change in direction of light when light ray passes from one medium to another is called refraction of light. So what is medium here? Medium is nothing but the place, okay, the place in which the light ray is traveling. So around us we have air, so air is one medium. Inside water also light does travel, so water is another medium. Inside glass also, inside diamonds, inside a resin, inside some some liquids, inside kerosene, and inside some other translucent or transparent materials also. Plastic is best example, glass. Okay, so these are all mediums in which the light can travel. In other words, the bending of light, okay, bending of light when it goes from one medium to another obliquely is called refraction of light. The refraction takes place when light enters from air to water. So refraction always takes place when the light ray is passing from one medium to another medium. The transition happens at that place, the refraction takes place. So here in white section we can see air medium, in blue section we see it is as water medium. Okay, what happens here is incident ray is coming, it will touch, okay, this is this line is a differentiation between air and water. Okay, and at that point where it will enter, okay, at that point where it will enter the water, from there if we draw a normal to the this surface between the surface which is differentiating between the air and water, it is normal, okay, and the angle between the normal and incident ray is angle of incident. So when it enters the water, we see that the light ray will bend towards the normal, okay, the light ray will bend towards the normal, and the bent ray is called refracted ray, not reflected but refracted. It is not reflecting back, okay, it is not reflecting back. We are not seeing here another ray, okay, which is being reflected, but rather it is being absorbed and refracted. So the angle between the refracted ray and the normal is called the angle of refraction. All right, so now what we have to, why does this happen is because in different substances, in different mediums, the amount or the extent to which the ray is bending towards the normal is different. The speed of light is different in different substances. The refraction of light is due to the change in speed of light on going from one medium to another. Thus, when light goes from one medium to another, its speed changes, and this change in speed of light causes the refraction of light. What happens is, in normal medium there is no obstruction like air, okay, there is nothing, vacuum. But in water, what happens is the speed of light will decrease. In air, if it is 3 into 10 raised to 8 meters per second, then in water it will be lesser. You will be learning what is that quantity, how much less. Okay, there is something called as refractive index also, which we shall be studying later. So because of this refractive index, okay, refractive index Ri of water is higher than the air or vacuum. If the refractive index is higher, then the speed of light will decrease. Because it will decrease, it is decreasing, it will be bent towards the normal, and that is why the light ray, when travels from one medium to another medium, okay, it will bend. Now we have been talking about medium, okay, we shall see what is a medium. A transparent substance in which light travels is known as medium. A medium means part of the space where light can travel is called medium, transparent. Medium can be divided into two types: optically rarer medium, and optically denser medium. Now don't confuse it with dense material and less dense material. That is why they have added optically. Okay, optically rarer medium, optically denser medium means through the point of view of optics. We are studying optics now, so through the point of optics, some materials are rarer means they are less dense, some are more dense. So optically rarer medium, a medium in which speed of light is more. Okay, the best example is vacuum. Next is optically denser medium. Next best example is water or glass, in which the speed of light is less. Okay, glass is an optical denser medium than air and water. Now water is optically denser medium than air, and glass is optically denser medium than water, and water in turn becomes optically denser than both of these. So there are some rules of refraction which we have to keep in mind. All right, so the first one is, when a light ray travels from rarer to denser medium, that is more speed to less speed, the light ray will bend towards the normal. Means here the speed is high, here the speed is low, so it will obviously bend towards the normal. Next case, what happens is, if it is coming from the denser medium and going towards the rarer medium, then the ray bends away from the normal, not towards, because here the speed was less, so it was towards the normal. Here the speed is high, so it will be away from the normal. That is how you remember it. Now just like we had studied law of reflection, we shall be studying law of refraction also. Okay, law of refraction. According to law of refraction, the incident ray, the refracted ray, and the normal to this interface of two transparent media at the point of incidence all lie in the same plane. This may sound confusing, but there is nothing. So incident ray, normal ray, refracted ray. Normal to the interface. Interface is nothing but this line which differentiates between two transparent media. Okay, that is called interface. So the normal, refracted and incident all lie at the same plane at the point of incident is what they are trying to say. Next, what they have given is the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. That is sine I by sine R equal to constant is what they are trying to say here. And this constant is nothing but the refractive index of the second medium with respect to first. Okay. So refractive index does not have any SI unit, because here we see that sine I, sine R both are in angle. Sine I also does not have any unit, sine R also does not have any unit. So it is obviously constant, and constants do not have any SI unit. So refractive index is just a ratio of sine of angle of incidence to the ratio of sine of angle of refraction. Okay. So we came across a new word called refractive index. So what is this refractive index? So here we shall see what is refractive index. The refractive index of a medium is defined as ratio of speed of light in vacuum to the speed of light in the medium. Means any light ray, if it is traveling from air to denser medium, optically denser medium, then the ratio of that the speed of light in, okay, it is given here in vacuum is given by C, obviously constant, to the ratio of speed of light in medium. What is the speed of light in medium? We will be knowing, they will be giving us. So when we calculate the ratio of that C by V, we get the refractive index of that medium denoted by N. Now both C and V are in meters per second, so obviously there will be no SI unit. So relative refractive index. Okay, what is relative refractive index of medium 2 with respect to medium 1? Means when we are comparing one medium to another medium, what happens that time is it is written as 1 and 2, superscript 1 N and subscript 2, N2 by N1. Okay, that is refractive index of medium 2 with respect to medium 1, V1 by V2. Both V1 and V2 are measured in meters per second. So N2 and N1 don't have units. So in such cases, one that is medium 1 with respect to 2 is equal to medium 2 with respect to 1. Both are reciprocal of each other. Here we have Snell's law of refraction, that is when light travels from medium 1 to medium 2, then 1 that is 1 with respect to 2, N2 by N1 is equal to sine I by sine R. Okay, that is what we have to remember. N2 by N1 is equal to sine I by sine R, or N1 sine I is equal to N2 sine R. That's simple. And some constant we have to remember here. The first one is velocity of light in vacuum or air. Vacuum and air both are very similar. Okay, the only difference is in air we have air, in vacuum we don't have air. That is the difference. So the speed of light there is, or velocity, rather we determine it as velocity because we are dealing here with directions also. So velocity, it is 3 into 10 raised to 8 meters per second.